So our objective for this experiment is to relate the analysis of fluid system to the principle of fluid flow as they apply to our daily life. What is laminar flow? Laminar flow refers to the orderly movement of fluid particles along clear paths or streamlines, characterized by straight and parallel streamlines. This phenomenon typically happens in narrow pipes where the fluid moves at low viscosity and high viscosity. It's also known as streamline flow or viscous flow. And what is turbulent flow? Turbulent flow is described as the movement of fluid particles in a zigzag pattern, leading to the formation of swirling eddies that result in significant energy loss. Unlike laminar flow, turbulent flow involves fluid velocity constantly fluctuating in both magnitude and direction at a given point. This type of flow is typically observed in wide pipes accommodating fluid flow. Before we continue to the real experiment, I would like to provide you with a straightforward diagram illustrating the concepts of laminar flow and turbulent flow. This visual aid will assist in clarifying this concept before we delve into a detailed experiment.
Assalamualaikum everyone. Today I will make an experiment about turbulent and laminar flow. What material we need is first a Tupperware, one butter, one pan, lighter, knife, hose pipe, and two Pringle cam as a step, and one double tape. Okay, let's go to the experiment. Okay, firstly, we need to draw the size of pipe and the metal cover. Let's go. Okay, now we need to cut the water cover into this size. Secondly, we need to heat up the knife to cut to the hose pipe size. Firstly, we need to heat up. That's all. Okay, after we heat up the knife, now we can cut the cover bottle. Okay, now we already cut the cover of bottle. Now we need to try if the hose are able to in the cover bottle. Now the hose can dive into the cover bottle. Okay, let's go to next part. Next step, we need to make sure the Pringle can hold the bottle like this. So we need to make double tape here and here.
Okay, next we need to attach the double tape on the both Pringles cover. Then we need to pull the other side of double tape so the water bottle can be attached on top of it. After that, we need to make a small hole on the bottom of bottle.
And then, after a small hole has been made, the bottle need to close with the cover so the experiment can be proceed. And then we need to connect the hose on the water pipe, and to make it stand and balance, we need to attach it on top of Pringles can. Now let's try and see if the experiment worked or not. As we can see, the experiment worked smoothly, and this is a turbulent flow and the bottom is laminar flow. Let's try once again. From this experiment, I hope you guys can understand what is defined by laminar flow and what is turbulent flow.
Assalamualaikum, my name is Ahmad Hakim and I will explain about concept of fluid. Fluid flow is a movement of a substance, typically a liquid or gas, through a space or conduit. This movement is governed by principle of fluid dynamics, a branch of physics and engineering concerned with behavior of fluid in motion. When fluid flow is experienced various phenomena such as viscosity, turbulence and pressure gradient, all of which influence its behavior. The study of fluid flow encompasses a wide range of applications, from understanding blood circulation in the human body to design efficient transportation system and optimizing industrial process. Engineering and scientists utilize mathematical models, computation, simulation and experiment technique to analyze the predict fluid behavior, and enabling advancement in field as diverse as aerospace engineering, environmental science and manufacturing. Understand the fluid flow is circular for optimizing performance and efficiency of system, ranging from the hydraulic machinery to environment remediation technologies. That's all. Thank you.
Hi everyone, my name is Teacher Zahira binti Muhammad Safi from the FA3E. So today I'm going to talk about the concept of laminar flow. But first, I want to show you this cool video I found. It's of a river flowing really smoothly, almost like layers of glass sliding along. Check it out. So what you saw is laminar flow in action. It's when fluid move in nice, orderly layers, kind of like cars sticking to their lanes on a quiet road. What's cool about laminar flow is how steady it is. There's no crazy mixing or turbulence, just a calm and predictable flow like pouring syrup from a bottle in a perfect stream. To help us understand it better, scientists use something called the Reynolds number. It's basically a way to measure how fluids behave and when things are nice and calm. Like in the video, that's when laminar flow happens. So, in a nutshell, laminar flow is like the peaceful river scene we just watched. Smooth, steady and really cool to see. It's important in lots of stuff like how water moves through pipe.
Hi everyone, I'm Taslia and I will be explaining about the concept of turbulent flow. For the definitions of turbulent, let's read together what's written in the slide. Type of flow fluid, gas or liquid flow in which the fluid undergoes irregular fluctuations or mixing, in contrast to laminar flow in which the fluid moves in smooth path or layers. So as you guys can see with the pictures provided, all the fluid looks chaotic and have mixing flow. How exactly you want to identify the turbulent flow? Let me list down some of the detailed characteristics of it. First of all, the Reynolds number for turbulent is above 4000. Then with the high velocity and particle path are really irregular. Let's move on to the differences of laminar and turbulent flow. As you guys can see, laminar flow happen in small diameter with low velocity, meanwhile turbulence happen in large pipe and high velocity. Let's get a clear view of these informations. This usually apply to our daily life, as for laminar is more suitable for rubber pipe at home, meanwhile turbulent are more to factory to make any juice or liquidy product. Turbulent flow can make the process of making the product faster to be done. Next point is the Reynolds number for laminar is less than 2000 and turbulent flow is above than 4000. So what happened between the 2000s and the 4000s? We call that as the transitional flow, which is the mixture of laminar and turbulent flow. And last but not least, as for the laminar, the flow are moving in parallel and the turbulent having a mixing flow. What about transitional flow? Well, the center of the pipe will have a turbulent flow and the laminar happen at the edges of the pipe. That's all from me. Let's proceed to the next presenter.
Now we're going to talk about the importance of laminar flow and turbulent flow in food industry. For laminar flow, firstly is precise mixing. Laminar flow is employed in the productions of beverages like fruit juice and dairy product. For example, in the manufacturing of yogurt, laminar flow ensure uniform distributions of fruit puree flavoring without causing shear damage to the yogurt matrix. Secondly, heat transfer. Laminar flow is utilized in the pasteurization of milk. Pre-pasteurization, the milk flows in a controlled laminar manner through heat exchanger, allowing for uniform heating and ensuring the destructions of harmful bacteria while minimizing thermal degradations of the milk proteins. Quality control. In the productions of chocolate, laminar flow conditions are maintained during conching, a process where chocolate mix is continuously mixed and aerated to develop flavor and texture. Laminar flow ensures consistent viscosity and particle size distributions, contributing to the quality of the final product. Last but not least, for laminar flow, packaging. Laminar flow is used in the filling and sealing of beverages containers such as PET bottles and cartons. By controlling the flow of liquid products, laminar flow minimizes foaming and splashing, leading to the more efficient filling processes and reduced product wastage. Now for turbulent flow, firstly is mixings and homogenizations. Turbulent flow is essential in the productions of mayonnaise, salad dressings, and sauces. High shear mixers induce turbulent flow to truly emulsify oil and water phases, resulting in stable emulsion with a smooth texture. Secondly is mass transfer. In the brewing industry, turbulent flow is utilized during mashing, a process where crushed grains are mixed with hot water to extract fermentable sugars. Turbulent flow enhances mass transfer, allowing enzyme to efficiently break down starches into sugars, where essential for fermentation. Thirdly is heat transfer. Turbulent flow is employed in industrial frying operation in a deep fryer. Hot oil circulates turbulently around food product, promoting rapid and uniform heat transfer, which result in crispy and evenly cooked fried food. Last but not least is cleaning and sanitizations. Turbulent flow conditions are crucial during cleaning in place, which is CIP procedures in food processing plants. High velocity turbulent flow of a cleaning solutions ensure thorough removal of food residues and microbial contaminants from processing equipment and pipelines.
Now I will tell about application laminar flow and turbulent in daily life. Okay, firstly is sauce while cooking. This technique involves cooking food in vacuum sealed with bag in water baths with laminar flow, ensuring even temperature distribution and consistent cooking result. And secondly, reverse osmosis filter. There are systems use laminar flow to ensure that water pass through the membrane smoothly, effectively removing impurity without causing turbulence that cause damage the filter. And lastly, air conditioning and ventilation. Laminar flow is using in HVAC system to ensure a smooth, consistent distribution of air, improving indoor air quality and comfort in homes and office. Let's go to turbulent flow. Firstly, turbulent flow is combustion engines. In internal combustion engines, turbulent flow of air-fuel mixture improves mixing and combustion efficiency, leading to better engine performance and reduced emission. Secondly, river and oceans. Natural water bodies exhibit turbulent flow which help mix nutrient, oxygen, water and transport sediments. This flow with vital aquatic ecosystem. And lastly, cooking. Sterile liquids in cooking creates turbulent flow, promoting even heat distribution and mixing of ingredients. Okay, that's all for me. Thank you.